Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And I'm Jocelyn. For math homework help, call in Bakersfield 636-4357. Everywhere else, call 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
A lot of different ways to get a hold of us, aren't there?
Yes.
A lot of sixes in those phone numbers too, huh? All right. So Jocelyn, where do you attend school and what grade are you in?
I attend school in Panama Elementary, and I'm in 5th grade.
And have you been at Panama for a long time?
No,
This your first year, second year?
second year.
Second year. So how do you like it compared to your previous school?
It's fun. I like the carnivals too.
Oh, you like the carnivals?
Yeah.
You guys just have a school carnival? Is that
Yes.
what's going on? What was the best thing at the carnival?
Probably all the games and all the free candy.
Oh, all the free candy, right? Just say, that would be pretty good, right?
Yes.
Free candy tonight too?
Yes.
Halloween, right? So you
Yes.
get some
I
free
hope
candy.
so.
Yeah. So do you dress up and go out as dressed up?
Sometimes.
What do you dress up as?
I don't know.
Do you remember any of the costumes that you've had before?
A unicorn. That's all I remember.
Okay.
remember.
So how is 5th grade?
It's fun. It's kind of hard. The math is kind of hard.
Well, good. But do you like that?
Yes.
All right, good. And you're working on decimals right now, correct? All right. Well, before we do any of your problems, you're first going to help me out with today's social media problem of the day. You ready for that?
Yes.
All right. Let's take a look at it together right now. It says, how many pairs of opposite sides are parallel? So first of all, do you know what parallel means?
Yes. When two lines are never going to touch no matter how far they go.
Good. All right. So do you have any idea what shape that is? How many sides are on it, first of all?
6.
All right. And do you know what a 6-sided figure is called?
An octagon?
Hexagon.
Oh, hexagon.
All right. So think about pentagon is 5 because you hold a pen with your hand, you've got 5 fingers. Hexagon has an X. What number has an X in it? 6.
6.
Right? Octagon, octopus, has how many arms?
8.
So an 8-sided figure, like a stop sign, right? These are just little things that help some kids remember. You might like, oh man, I don't really need to remember that. I got it some other way, all right? So anyway, so we have a hexagon up there. How many pairs of opposite sides do you think are parallel? And can you describe them to me as we look at that?
I would say D.
D3?
Yes.
Why do you say that one?
Because there are 3 sides parallel to each other.
Okay. So can you describe them? Let's say we start at the top. Okay, that very top line. Is there a line parallel with that?
Yes.
Which one?
The bottom one.
The bottom one, right? So it's an easy one. So let's go clockwise. So the one that would be between, let's say, 1 o'clock and 3 o'clock. Is there a line parallel to that?
Yes.
And where would that one be, do you think?
The one in between the 7 and 8.
Good. That's a nice way to describe it, right? All right, so there's your second pair. And then if we go down below where it would be between 3 and 5, let's say, is there one parallel to that?
Yes.
And where would that be? The only one on the left, right?
Yes.
Okay. So you're going to go with 3 parallel pairs, correct? All right, let's take a look and see if you are correct. There you go. D3 is correct. First problem's done, all right? Feel pretty good about that one, huh? All right. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News. So, Jocelyn, you're going to help me out a little bit with this one. And Scott, you also. But we're going to start with Jocelyn. Do you have any idea who Taylor Swift is?
Yes.
Who is Taylor Swift?
A famous singer.
A famous singer. Very good. Scott, do you have any idea who Travis Kelce is?
Yes, football player.
Football player.
There you
All right,
go.
so you guys are both in tune with what we're going to be talking about.
All right.
Do you have any idea why I would be talking about Taylor Swift and Travis Kelce?
No.
Very good. Well, that's what you're going to learn today. All right. So we can take a look at the first slide that we have here, Taylor Swift's impact. So have you seen anything about her in the news recently at all?
No.
Well, all right. Well, you know, you're busy with fifth grade, so you don't need to be keeping up on all that stuff. So the economy, the Eras Tour. Have you heard about this Taylor Swift tour that she was
Yes.
on? All right. So you have heard about some stuff, right? Big thing over the summer. I'm sure that's when you were focusing on it, right? Not during school. All right. So projected to gross $5 billion in consumer spending. That's only in the United States. All right. So when she goes and performs, or this is shown someplace, it generates a lot of revenue for the community that it is in. Okay? So Taylor Swift recently became a billionaire based on her music alone. You and I know Magic Johnson, all right? Basketball player for the Fakers, the Lakers, back many, many moons ago
Tough crowd
in
here,
Los
Dave.
Angeles. Well, see, being a Knickerbocker fan, I got, you know. But anyway, we go by that. So Magic is now a billionaire,
Yeah.
but he only has a fraction of his money, not even half, like less than that from basketball. The rest is all from investments.
Right.
So he's done well with investments to make himself a billionaire, other than just the one thing that made him famous, right?
Yeah.
So, but Taylor Swift has made all of her music, all of her money just on music, not on investments or things like that. So here's the other part. So Taylor Swift is dating a football player, Travis Kelce, okay? And they make a big thing of this, right? So the ratings, they can see, they're talking about here with the NFL, the ratings, how they grow. Chiefs tickets, people buying tickets to go to those football games because they think they're going to see Taylor Swift at the football game, right? And then Kelsey's jerseys, right, increased by 400%.
Wow.
Okay, that, I mean, just to double it would be 100%. So you're doing that over and over and over again. So there's a lot of money being made there. So with Swift in attendance, Travis Kelce's team is 4-0. So when she's there, they win. When she's not there, they just happen to lose, all right? Whether or not this is the determining factor, okay, just happens to be, all right? But we can see that Kelce is getting 108 yards per game when she's there and 46.5 yards when she's not there. So I said, well, let's take a look at those numbers and figure out the percent of decrease when she is there or not. So here we have you seen this percentage formula before for doing increase and decrease?
No.
You're in fifth grade, right?
Yes.
Well, guess what? When you're in sixth grade, if you're lucky enough, you're going to get this formula. All right? So if it kind of makes sense to you today, and you see the example that we do, and you go, yeah, it kind of makes sense, you're going to be ahead of the game. All right? So we're going to take the original value, decrease it by the new value. All right? That's all that means. When you see a bar like that, do you have any idea what operation that means?
No.
That means divide. All right, so when you have a fraction, if you have 2/4, right, it means 2 divided by 4, right, which would be 1/2. Okay, if it was 4/2, what would that mean?
4/2.
It would be 4 divided by 2,
2.
which would be 2. So this simply means take these two numbers, subtract them, and then divide it by the original value. You're going to get a decimal. Then you're going to take the decimal, multiply it by 100, and that is your new percent. Make sense?
Yes.
Because percent, you know what the word percent means?
No.
It means out of 100. So that's why we're multiplying it by 100 at the end. See all the new stuff you're learning already today?
Yeah.
All right. So let's take a look at what Travis Kelce actually does. So he had 108 yards during the wins. We're going to subtract the 47 because we're going to take 46.5 and round it. So then we take that number, okay, and you're going to divide it by the 108, which is the original. You're going to get the decimal, which is 0.564, multiply it by 100, which just means move the decimal 2 places. Have you ever heard of that?
Yes.
Okay, and that's how we get 56.4%. So he does 56% less when Taylor Swift is not at the stadium. Kind of makes sense?
Yes.
All right, good. Well, that's today's Math in the News. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. And since you have done some excellent work so far, kind of going along with that, and the social media problem of the day, it is time now for you to get busy on some of your regular math problems. Are you ready? All right, head on over to the board with Scott. And Jocelyn, you said that you were working on dividing decimals, correct?
Yes.
So why don't you put an example of one that you've been doing and discuss it with Scott and kind of explain to him how you're doing these problems.
Okay.
All right?
Okay, what do we got? Oh, I gotcha. Okay. So maybe you have a whole number as the divisor, right? And then you're going to divide it into 42.3. All right, what are you going to do with this?
So
Do you have to move any decimals before you start?
yes.
Okay, tell me about
Move
that.
This one up here.
Okay, gotcha. So you got to make sure that we know for sure it's going to go right in that area. And that's
Yep.
important because that's going to be the place of the decimal in the answer. Good. All right, what else?
So then we're gonna divide 42 by 6.
Okay,
and
what
we
about
get
4
7.
though? Does 6 go into 4?
Oh, no, we can't.
So,
we would
the
put a
question is,
0.
yeah, that was what I was going to ask. Can you put a 0 there? Is that okay?
Yes.
You could, right? Yeah, definitely. You don't have to, but you could. All right, what's next?
Then you're gonna move over to the second digit,
Uh-huh.
and you're gonna divide these two
Good.
by 7.
Okay.
Because 7 times 6 is equal to 42.
Right.
And then you're gonna subtract 42 and get 0.
Okay.
And then we're gonna bring down the 3.
Good.
And 6 cannot go into 3, so we would put just the 3 right here.
Oh, let's try again. So I love what you said right till the very end of that part, and I like that you brought down the 3. How many times does 6 go into 4?
7.
No?
Oh, 0.
0, right? And you put a 0 there. How many times does 6 go into 3?
0.
That's right. So we got to put a 0 up there. Now, at the end of this decimal, like if you were going to make this into money, right? $42.30. What would you put after the 3?
A 0?
Can you put a 0 there?
Yes.
Go ahead and put a 0 here, right? So no, not there.
Oh.
Not there, down here. $42.30 is what we're looking at, right? Okay, so that's the one that comes down. Okay? So you can add 17 more zeros if you wanted to, because none of them really make all that much difference. They don't change the value of the number, but they could help you divide all the way out to make sure you can actually get a number that ends, right? And I like the way that you did this one here. I'm going to finish up your 0 here, and then I'm going to give you a little bit more room to make sure you can finish off this problem. So you drop down the 0, and now what you're doing is, really important you put the 0 there. How many times does 6 go into 30?
5 times.
There you go. Kind of
So we're
nice,
gonna
huh?
put the 5
Now
up
we're not
here.
going to have any random numbers floating around at the end.
And then we're going to put 30
Uh-huh.
and subtract that and get 0.
That's it. You got it. So nice job on that one. When you have a decimal inside the divisor, right, then you're going to go ahead and move it up to the top. What if you have a decimal outside?
Then you're going to move it over.
Okay, show me real quick. How about if we have 0.5, and we're going to divide that into 62.5.
So what we would do
What do you
is we would bring the decimal over here,
Okay?
and we would put the decimal right here,
Okay.
and then we do the same here. So we'd bring the decimal right there one time,
Okay?
and put the thing right there.
That's exactly the way I've learned it. And the big question of the day is, why?
Because you can't divide this into that.
Why not? I mean, we're smart people. We could do that if we wanted to, right? If you
Yes.
punch in the calculator, it works. That's nice. How come you can't do it? It makes things a little complicated sometimes,
Yeah.
huh? And I think sometimes when we're doing some math, we don't think about that question. Why are we doing this? This is the way I was taught. This is the way we're going to do it. When you divide by a decimal, things get a little wacky. We don't want things to get all goofed up because we'd like to be able to have that number be a whole number right here. You just showed us a wonderful example of what's happening. So in order to make that happen, you move it over one time. Great. You have to move this one over as
Yes,
well.
So it's
And-
the same.
Yeah, they have to be the same. And you're not just moving it over. You're not just moving it over one spot randomly because I want it to go over one spot. What you're really doing is you're multiplying both of them by 10.
Yes.
Okay? Just like we saw in the example in Math in the News, you're allowed to multiply by 100 to get a percentage. Same thing here. You can multiply this one times 10 to move the decimal over, but you have to do the same thing to that one. And I'm glad you did that. Okay, so in the answer to this problem, where is the decimal going to be?
We would
In the answer at the top there. Where are you going to put the decimal?
right here.
That's it. Super important, like you did in the first one, to make sure the decimal's in the right spot. Okay, go get them. This shouldn't even take too long because I know you're really good at this.
So then we would divide 6 into 5 into 6.
Yes.
And we can do that only one time, so we
Good.
subtract the 5,
Uh-huh.
get 1,
Yep.
bring down the 2, divide 12, oh wait, no, divide
No, you're
5,
right.
oh, divide 12 by 5,
Uh-huh.
and we would get 2,
Good for you.
so minus 10, and then we'd get the 2, bring down the 5,
Mm-hmm.
and 25, 5 can go into 25 5 times,
That's it.
so we'd put the 5 right there.
That's it. And go ahead and just finish up real quick just to make sure we don't have a remainder. That's awesome. So 2 different ways to divide. If the divisor out here has a decimal at the end, you can just go right to it. If it has a decimal anywhere else, we want to make that decimal go to the end, and you got to change the other number.
All right,
Super good
Scott, I'm going
start.
to give you guys 1 minute, and I don't care which one of those problems you do, but how can you check to make sure that those are correct? Only one of them I'd like you to do that.
Which one?
And you have
First of all, pick a problem.
under a minute to
Okay.
do that.
Pick a problem.
This one.
That one right there. How do we know if that answer is right?
We would multiply it
So this division problem, we do the opposite. We multiply what times what?
5 times the answer.
That's it. Let's do it real quick. Write it down. 125 times 5.
5 times 5 is 25, so
Yeah.
put the 5 right here.
Good for
Bring
you.
the 2. Put, multiply 2 by 5 is 10 plus a 2,
Yep.
12. Put the 1 over here.
Yep.
5 times 1 is equal to 5
Mm-hmm.
plus 1 is 6.
Yep. And basically, at the very beginning, we had a 0.5, so we'd have 62.5 there too. Good job.
There you go, nicely done. So that way you checked it right there. For some great work so far this afternoon, you've got yourself a meal courtesy of our friends at the Broken Yolk Cafe, so congratulations on that. So I do have another problem for you, Jocelyn. Did you know that you could do math on the piano?
No.
Well, we're going to check that out right now.
Hello, so my name is Mark Musa, and today I will be explaining the Fibonacci sequence on the piano and then playing it for you. And so the Fibonacci sequence is a sequence of numbers. So let's say it's 0 and 1. When we put 0 and 1 next to each other, it adds up to 1. Then the 1 from 0 and 1 adds up to the other 1, which adds up to 2, and so on and so forth. So in the spiral, or the golden rectangle, which is done on graphing paper, 2 squares here add up to 2. So when they add up to 2, the next number would be 3, because 1 plus 2 equals 3. And so then 2 and 3 equals 5, 3 and 5 equals 8, and so on and so forth. I've written the letters and their numbering on a piece of lined paper. As you can see, it says D sharp is 0, E is 1, F sharp is 2, G sharp is 3, A is 4, B is 5, C sharp is 6, D sharp is 7, E is 8, and F sharp is 9. So I'm gonna play it now, and this is how it's going to sound. And that was the Fibonacci sequence on the piano. Thank you very much.
And that was awesome, a little Fibonacci on the piano right there. And speaking of music and math, we'll have a little bit more later on this hour as well. But right now we have Jocelyn, a 5th grade student from Panama Elementary, in studio with us. and you are working with decimals that you and Scott just did, but that's what you're doing in class right now, correct?
Yes.
So you're comfortable with decimals. And you know that 5th grade is going to be a big year for you mathematically, right?
Yes.
And we were discussing this a little bit before, because there are 3 main things you're going to do in 5th grade that you're going to do for the rest of your life. One is decimals. Do you remember what the other 2 were?
Percentages and fractions.
There you go, all right? So fractions, decimals, and percents, you're going to do a lot this year, and you're going to do them in 6th grade again, but a little more difficult. And guess when you're going to do them again?
7th grade?
You're correct. And guess when you're going to do them after 7th grade? Do you know when, after 7th grade, when you're going to do them again?
College?
Well, you're going to do them in 8th grade.
Oh, 8th grade.
And then when do you think you're going to do them?
9th grade?
9th grade, there you go. And do you think you'll be done with them after 9th grade?
No.
No, when will you do them again?
10th grade?
All right. And let's say you do them in 11th and 12th grade. When will you do them again?
In college?
You going to go to college?
Yes.
All right, so you're going to do fractions, decimals, and percents in college. Now, when you get through with that, do you think you'll be all done with that stuff?
No.
When do you think you'll be doing it again?
In job?
Yeah. And how long after that do you think? Let's say you retire. Are you done with fractions, decimals, and percents?
No.
When are you going to do them again?
With money?
Yeah, with money, right? I mean, so are you ever going to start doing fractions, decimals? No. So the sooner you get them and the better you understand them, the easier everything's going to be, all right? So head on over to the board. You and Scott can work for a couple minutes. So Jocelyn, just put up any fraction you like. Any one you want. And then tell Scott the different parts of it and kind of anything that you know about them. If you can simplify them, any vocabulary that goes with them and stuff like that, and then I'll let you guys know where to go from there, right?
Okay.
Go ahead.
What do you think? So we have 4 bar 8, 4 over 8. What do you know about this?
Well, we're taking
Well, the 4 is the top number.
Yes.
Do you know what the top number is called in a fraction?
Numerator.
There you go, a numerator. Do you know how to spell it?
no.
Okay, so we have the numerator. What about the bottom number?
Denominator.
Okay, you got to at least try that one. Denom, D-E-N-O-M. Yeah. Kind of like a Terminator. You got it. That's it. Denominator, numerator. All right, good. So we have a fraction here, right? 4 over 8. And you were just about to say something else, and I think you were on the right track. What do you know about 4 over 8? What does it mean? Is there another way to write it?
Yes, you can
Okay.
simplify it.
Yeah, you could simplify it, but let's not get there yet. Almost. How else could you write 4 over 8? Is there another way to do it? In other words, in your problem on the Math in the News today, there was a fraction. And we talked a little bit about what that means. What does that bar mean in math?
Dividing?
It does, that's right. So you could write 4 divided by 8. Fractions mean divide. That's what they mean. Okay, that's really what that means. That's what it's all about. Okay, so you said we could simplify it. What does that mean?
We're making the fraction smaller.
Aha, now I like how you said there, but we're going to need to make sure we're real clear about what's going on, okay? We never want to change the actual value of the fraction, because that would just make all the rules of math go out the window. That's no good. We don't want to change the value of it. Maybe the numbers will get smaller, but we want to keep the value the same, right? We want to say 4 over 8, right? That has a certain percentage, has a certain fraction, has a certain decimal associated with it. We don't want to change that, but we can change how it looks. That's fine, okay? So maybe the numbers, both of them can get smaller, but the value will stay the same. So how do you do that?
So if this number can go into, if the numerator can go into the denominator, then you can divide it.
Okay,
So,
so let's see what that looks like.
equal to, oh wait, did I do that?
Yeah, you're thinking a little bit, huh? Okay, so you said this one goes into that one. We might even do that one into that one. Let's look at it this way. What number could you divide both of those numbers by? What number would go into evenly, right? Give you a little hint there.
2?
Is there a different number?
Yes, 4.
Yeah, there is. There's a couple different numbers, right? So the first one we're going to try here is 2. So what's 4 divided by 2?
2.
2. And what's 8 divided by 2?
4.
So this is a fraction as well, and these two fractions are equivalent. They both have the same value, okay? You can't just randomly say, you know what, I want that 4 to be smaller, we're going to go ahead and make it into 1 over 8. These two fractions are not the same, right? We can't just make the numbers smaller. We have to make both of them smaller in a very specific way. So you also said instead of 2, we can do a 4, right? So right over here, can you make sure you can tell me what's going on there? What's 4 divided by 4?
4.
It
I'm
is-
2.
no,
1.
Keep going, 1, there you go.
1.
What about on the bottom? What's 8 divided by 4?
2.
So all of these fractions that we've created, they're all equivalent. 1/2 and 4/8 and 2/4, they all have the same value. And one way to be able to show that is, do you know the decimal that's associated with a half?
0.5.
It is, that's right, like half of a dollar, right? 0.5. So if you were going to change the 1/2 into a decimal, it would be 0.5. What do you think the decimal would be if you changed 2/4 into a decimal?
0.5.
Good guess there, well done. What about 4/8?
0.5.
That's right, what about 1/8? Not 0.5, right? That's why you can't just randomly change numbers.
Well,
We've
good. I'm
kept
glad
the
that
same
you
value.
guys were able to talk about that
Yeah.
and how, when you simplify, it's not reducing it. Because those are two different things. Because sometimes you'll hear instructors go, reduce it for me.
Yeah.
But that doesn't mean simplify it, because if you simplify it, the quantity stays the same. If you reduce it, you alter the quantity. Does that make sense?
Yes.
Good. So nice work right there on that. And we're going to get you going, because I saw you were going decimals, and then we'll get into percents and stuff like that. We'll do that in a little bit. But right now, it is time for a little more music and math. All right, here we go, the math of music. All right, today we have from the Panama Buena Vista Union School District, Braxton with us today. How are you, Braxton?
I'm doing well. How about you?
I'm excellent. Thank you for coming in this afternoon. So, where do you teach music in the district?
I teach at Williams and Stein Elementary.
All right, and do most music instructors work at two, or is that unusual for you to be at two different places?
Yeah, most of us in elementary teach at 2 schools.
All right, and how long have you been a music instructor?
This is my 3rd year in Panama Buena Vista. Prior to that, I was teaching in Bloomington, Indiana for about 3 years.
Okay, and how many different instruments would you say are you proficient at?
I am proficient in probably about 4 or 5.
And the ones that you brought today are the ones you're most proficient, or you like the best, or?
The most applicable to what I'm going to be talking about later.
All right, good. So what will you be doing today?
So we're going to be talking about timbre and colors of sound. So timbre is, if you look up here, it means the way the instruments sound, what make them unique to themselves. So this instrument that I'm playing right now is a bassoon, which is a lower instrument. And it sounds like this. And this instrument I have next to me is another low instrument, the cello, and they play it usually around the same notes. And cello sounds similar but a little bit different. And what makes these instruments sound different is the timbre. And the timbre comes from this word called the overtone series. So, hey, can you help me out with something?
Yes.
So if you look up there, we have different numbers, right? Mm-hmm. So we have 4. Now 4 is like my open string. Now, can you tell me what is 4 plus 4?
8.
8, yeah. So if I press up higher, on each side of the string, it's vibrating at 4 and 4, which is 8. We can also say like 4 plus 4, or what's another way we can explain that?
4 times 2.
Yeah, 4 times 2. So 2 sides, right? Mm-hmm. And then that next one, what do you see? How many 4s do you see?
3.
3. So what's 4 times 3?
12.
12. So again, if I cut my string a little bit more, and I just had to press it in one spot, it produces a higher sound. And we can keep going all the way up to, like I said, halfway, times 2, times 3, times 4, all the way up, all the way up to kind of infinity. So that's what produces different sounds on instruments, is by multiplying the original notes, our lowest string. Okay. Now on other instruments like the bassoon, we have the similar thing, but unfortunately bassoon isn't as easy as cello is. On cello, I can press my fingers down and produce different notes. On bassoon, we have to press different keys. So on bassoon, I have all these keys for my hands on the front, and then even more in the back for my thumbs on this side. So I can do the similar things, playing that low note, our first one. And if I cut it in half by lifting up this finger, produces the same note but up higher, and so on and so forth. So those are different notes that are all produced by the same fundamental root notes that we talked about in the overtone series. Do you have any questions for me about that? Any questions about the bassoon or the cello? No? And you play an instrument, don't you?
Yes.
What do you play?
A violin.
Ah. Well, violins are okay. I'm a violinist too, so I love playing the violin too, but right now I've been playing a lot of cello and bassoon, which have a lower instruments. Yeah. So that's it on the overtone series and timbres of instruments.
All right, nicely done. So, Braxton, what was it that first got you into music? Because you said you started in Bloomington, correct?
I started in Bakersfield. I actually grew up in town, and I went to Loudon Elementary, and then I went to Thompson, and then Ridgeview. I wanted to be a music teacher from pretty young and decided to pursue music, so I went to LA for a while and studied there, and then went to Indiana for a few years and studied there also.
Okay, so that's where the Indiana part comes in.
Yes.
So you are a product of right here in Bakersfield.
Yep.
And how old were you when you first started playing different music?
I was in 5th grade.
All right, and the first instrument you had was?
Was actually a violin.
All right, so the same thing as Jocelyn
Yep.
right there. So who knows, maybe in 15 years or so, we'll have Jocelyn back on the show, and she'll be sitting right where you are and instructing some other young student about that.
Sounds
All
good.
right, Braxton, thank you for coming in today and sharing a little bit about music in math with us. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. And another exciting thing, always to find out what's new this week at NASA.
Celebrating International Observe the Moon Night, NASA leaders gather for an interdisciplinary space conference and the release of a new graphic novel. A few of the stories to tell you about this week at NASA. On October 21st, people from around the world participated in International Observe the Moon Night, an annual event. NASA invited people to take part in celestial observations, learn about lunar science and exploration, and honor personal and cultural connections to the moon. As an agency, NASA has a legacy of lunar exploration, from Apollo to our Artemis missions. The moon is a stepping stone to understanding more about our solar system, galaxy, and universe. Learn more at moon.nasa.gov. Deputy Administrator Pam Melroy and NASA officials participated in the Accelerating Space Commerce, Exploration and New Discovery, or ASCEND conference in Las Vegas. NASA astronauts Laurel O'Hara and Jasmine Mogbelli spoke to the conference live from the International Space Station. During the conference, panels and exhibits about NASA's space technology development, human sustainment, and radioisotope power systems were attended by government, academic, and industry professionals. The second issue of NASA's graphic novel series, First Woman, was released on Thursday, October 26th. First Woman, Expanding Our Universe, and its accompanying digital content showcases real technologies that will make living and working on the moon and eventually Mars possible. Other resources include a digital mixed reality environment and STEM resources available in English and Spanish. To learn more, go to nasa.gov/CaliFirst. NASA's Langley Research Center in Hampton, Virginia, opened its doors to the public and media on Saturday, October 21st, for the first time since 2017. People were invited to learn more about the center's innovative aerospace research. Center Director Clayton Turner and NASA astronaut Victor Glover met with the members of the public and media in several of NASA Langley's over 200 facilities. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Always fascinating and interesting things going on at NASA. Are you interested in space at all?
Yes.
Would you like to work at NASA, do you think, if you had the opportunity?
Yes.
Do you have any idea what you would have to do if you worked at NASA?
A good guess would be fractions, decimals,
Yeah,
and
there you go.
percents.
That's what I was going to see if you remember those three things, right? So you're going to have to do fractions, decimals, and percents, because a lot of times we have folks from NASA on the show with us, and we talk to them about what they do and how they got started and things like that, and they talk about the math they do. And a lot of it, I think one person actually said, oh yeah, the stuff that we did in 5th grade is the stuff that we do all day, because that's when you first get introduced to fractions, decimals, and percents. Can you remind everybody the social media places that we have?
We have Facebook, Instagram, and Twitter. Twitter and YouTube, sorry.
Yeah, so right. So on Twitter, actually, somebody sent in a problem, and we're going to go ahead and have Scott work on that problem right now. So hopefully that person is viewing the program, and we'll get a little bit of help from this.
All right,
Scott.
so it looks like we're adding some mixed numbers here. Mixed numbers where you have a whole number and a fraction. Problem says 2 1/3 plus 7 minus negative 6 1/2. So a couple things we're going to look at here. We want to make sure we take care of these parentheses first, because in your order of operations, we want to make sure the parentheses are done first. Nothing to simplify in the parentheses. However, we do have a negative and a negative together. Make a kind of a neat little face, right? If you have a little happy face there. But 2 negatives in a row usually make a positive. The other way you can think about it is the number on the outside actually is a 1 that you don't see, and you're multiplying it times the 1 on the inside. Negative times negative is a positive. So I'm going to rewrite this problem. 2 1/3, we haven't changed anything there. Plus 7, we haven't changed anything there, but I'm going to rewrite it without any parentheses, and now the minus negative number is going to be a plus 6 1/2. Should be kind of interesting now. I think we can take care of that 7 as well, and you can make it go to the 2, or you can make it go to the 6. It doesn't really matter, but we'll go ahead and combine these two whole numbers here, and we'll get 9 1/3 plus 6 1/2. And then people have different ways of doing this as well. Some people like to change the entire mixed number into an improper fraction, and this entire mixed number into an improper fraction. And then you got to make sure you have the same denominators. All kinds of things to do there. When I was teaching this stuff, I usually like to line these up a little bit differently. And I'm going to show you how I do that now. 9 1/3 and 6 1/2, and I line them up and down vertically instead of horizontally. Here's why I do that, because next to each one of these fractions, you can make a new denominator fraction so that both of these numbers have the same denominator. What do you think? What would be the least common denominator between 2 and 3? And sometimes you don't even need the least one. What should we use as a new fraction denominator? Any idea? What's 2 times 3?
6.
That's it. Good guess. So we're going to put a 6 down here. And here's how this works. I got to make 3 into 6. I'm going to multiply by some number. That number is 2. That means I have to multiply times 2 on the top as well, and I get 2 6. So just as we were talking earlier about making sure we don't change the value of the fraction, the same thing happened here. We're not changing the value of the 1/3. We're just changing how it looks. We're multiplying the top and the bottom by 2. Same thing with the 1/2. I got to make the 2 into a 6. That means I'm going to multiply by 3, but that also means you need to multiply by 3 on the top. And we make 3 6. Now we can split this whole problem up. We can have the whole numbers on the left, we can have the fractions on the right, and we should be able to simplify the best we can. Let's go ahead and add the fractions first. When you're adding fractions with like denominators, in fact, that's the only way you can add them. You have to keep that same denominator. Then you can add the numerators together. 2 plus 3 is 5. Then we can add the whole numbers. 9 plus 6 is 15. And one more check. Is there anything else we can do? Can we simplify the 5 6? We sure would like to if we could, but there's no way we can make those numbers smaller without changing the value of that fraction. So it's all done. 15 and 5 6.
Well, hopefully that helps out the person that sent that problem in.
Yep.
And so that was the first time you've seen a problem like that also, right?
Yes.
Good. So that way you've been exposed to it. And when you start working more with fractions, you're going to be doing problems like that. Did you know what mixed numbers were before that?
Yes.
Oh, good. So you're ahead of that. All right. So here's what we're going to do. Jocelyn, since you know a little bit about that, why don't you head over to the board with Scott right now. And Scott, what I'd like you to do is we're going to come up with a problem, and let's start with a fraction.
Okay.
All right. Then we're going to do as you guys did before, turn it into a decimal and then turn it into a percent. You can do all 3 of those in 3+ minutes.
All right.
All right.
Any idea what kind of fraction? We don't want to make the numbers too big, right? Like I like the numbers you chose last time, which was 4 over 8. What are the kind of fraction do you think we can make? How about like maybe, I don't know, 2 over 8? Can we try that?
Yeah.
2 over 8. All kinds of things you can do with this fraction. What would you like to do with this fraction first?
Simplify it?
Okay, let's simplify it, because you know that you can actually do that part, and we might as well start off on a good foot with something you can do. Okay, let's go ahead and simplify. What number can you divide into 2 and into 8 both?
2.
That's it. Go ahead and show it right down the next to it. So you can say divided by 2. Good for you. And so we're not changing the value, we're just changing how it looks, right? What's the new fraction?
It would be 1 over 4.
That's it, because 2 divided by 2 is 1, and 8 divided by 2 is 4. So now we're going to look at this fraction, 1 over 4. What else can we do with it? Can't simplify anymore, but we mentioned 2 other things. Love to be able to change it to a decimal, right? Love to be able to change it to a percent as well. Do you know how to change a fraction into a decimal?
No.
Well, here's the wonderful part. It goes back to the very first problem we did today. It's division, right? What does 1 over 4 mean? 1 divided by 4. That's it. So how would you write that? I'm going to go ahead and write your little bar here. How would you write 1 divided by 4?
The 4 and the 1.
Think so? Let's switch them around.
And I'm glad she did that
Yeah,
because
I am too.
99% of the students will do that.
Yeah, that's
So
exactly
kind
right.
of talk a little bit about why it's not like that.
Sure. And so if you think about, like, if you have, let's say you have 9 over 3, right? And you have, what's 9 divided by 3?
3.
This is just 3, right? And so really what you want to do when you're making this problem, you want to put the bottom number here, and you want to put the top number here. And you can see the answer, right? 3 to 9 goes 3 times. So you can kind of see why that's the case. And now that we want to do the same thing. We want to change it up a little bit, right? How many times does 1 go into 4?
4 times.
4 times, right? But the answer to this is not 4. It's smaller than 1, so the answer wouldn't really make sense very well, huh?
Yeah.
Can you change those around real quick? There's going to be a 4 on the outside. That's it. So we'll do a 4 on the outside and a 1 on the inside. Does 4 go into 1?
No.
It doesn't. So let's do what we did in the very first problem. Where's the decimal on the 1?
They're right here.
That's it. Every number in the world has a decimal, doesn't it? So where's the decimal going to go in the answer?
Right.
Right there. What can we put after the decimal that won't change the value?
0.
You can put a 0. How many do you want to put there?
2.
How about 17 of them? Could you do it?
Yeah.
You could if you wanted to, right? You could put 3 or 4 more if you wanted to and not use them if you didn't want to, but 2 is a good start. All right, so now we can do this problem. How many times does 4 go into 1?
0 times.
It goes 0 times. You can keep that there. Good. How about 4 into 10?
2 times.
All right, you got this now. Go ahead. Keep going.
4 minus 8.
8, yeah.
And 2.
Yeah, and you're going to bring down the 0, right?
Yeah.
Good for you.
And then 4 can go into 25 times.
It can. That's correct.
So we would put
Yeah, and make sure you finish up. There you go. We don't have a decimal, or sorry, we don't have a remainder left over. So if you wanted to change 1/4 into a decimal, it looks to me at this point that we have 0.25. Let's make sure that makes sense in our mind, right? Another word for 1/4.
1/4.
A quarter. How much is a quarter worth?
25 cents.
25 cents. So far, everything's kind of lining up, isn't it? Great. Okay,
And
so
you've
we have
got
0.25.
A little over a quarter of a minute.
Okay,
to
we're
keep
real
going.
quick. Do you remember from the problem on social media today, or sorry, probably Math in the News, how to make a decimal into a percent? Times,
10.
keep going, times
100.
100, that's it. So you're going to move this decimal over 2 places. What percent would that be?
25%.
Can you write it right there? That's it. Nice job. All 3 of them.
you go.
Decimal, percent, and fraction.
Good. So you guys accomplished exactly what I wanted you to do. Nice work right there. 636-4357 is that phone number. And if you've ever thought about working for a state park, here's a little more information.
We live the parks life, and so can you. At the California Department of Parks and Recreation, there are a wide variety of opportunities. At state parks, we seek to provide equitable access to parks and recreational programs while working to protect our state's unique resources. Join us in sharing California's great treasures. We are looking for people who reflect our state's rich diversity and are passionate about making a difference. So join us today. Go to livetheparkslife.com to learn more.
My name is Brianna Kennedy Feldhouse. I'm a state park peace officer here at Ocotillo Wells. Finishing field training and then becoming a solo officer is like everything else this process has been. It's been wonderful and terrifying and exciting all at the same time. With being solo, it's like, it's kind of, you go through all this training and you spend so much time in the academy and then so much time in field training that once the day comes where they say, okay, now you go, it's almost unreal. And you know, there are moments where you think, oh, I'm not ready, but you are ready. It's just the training wheels have to come off eventually and the safety net gets pulled, and it's amazing how quickly you fall back onto your training when you are in a stressful situation by yourself. As scary as that is, once you're actually in the field and you're doing it, it just winds up falling right into place for you. And that's kind of how I feel on some of my contacts. I mean, I'm not perfect. I have a lot to learn. I'm excited to learn. I'm excited to continue to grow and train and hone my skills, my investigative skills, my DUI skills, my just everything that comes along with being a proficient officer. I want to be somebody that people look to and say, she's squared away. I strive and continue to strive to maintain my personal self throughout all of this, and I think this department is the perfect place for that. I really, really love being here. I'm still able to be Brianna. I'm still able to be myself, and that's part of wearing multiple hats in this job, is that we're law enforcement, we're interpretation, we're resource protection, we're friends, we're people's, you know, safety blanket when they're scared, something happens, somebody gets hurt, and we have to be there to pick people up. It's an incredible experience, and like I said, it's greater than I could have ever imagined. I've got a great team here. You know, just like in the academy, I came in and was welcomed with open arms. There's real strong sense of community within state parks here, specifically at Ocotillo Wells. From start to finish, this whole process and where I am today has just been wonderfully surprising, and now I've found the things that I enjoy about the job, and I know I want to become, you know, an instructor on EMR. I'd love to become K-9 officer. I would love to become K-9 officer. I've already been putting the bug in everybody's ear over here to send me to training, so that way I can do that one day. So the future for me is endless. My name is Brianna Kennedy Feldhouse. I'm a state park peace officer here at Ocotillo Wells, and we are parks.
All right, so Jocelyn, have you given any thought about what you might like to do in your future?
A fashion designer.
A fashion designer. There you go. All right, nice. Need fashion designers, right? Scott and I need to keep up on our fashion and stuff, but I'm sure we're the least of your concern right there. Yeah, okay, guys, right. So I know what you're going to do in your immediate future. Do you know what you're going to do in your immediate future? That's right, fractions, decimals, and percents. But we're going to do fractions right now, all right? Head on over to the board. So we're going to have Scott work with you on adding fractions first with like denominators and then unlike. Go to it.
What do you think? We're going to have two fractions we're going to add together, okay? So we're just going to make these blank real quick. What number should we put on the bottom as a denominator?
8.
8? All right, let's put an 8 on the bottom. We've been working with 8s for a while, and that's kind of nice, okay? On both of them. We're going to make an 8 on both of them, okay? So before we even know what these fractions are, here's a great way to look at this problem. And in fact, if you get a chance when you do adding fractions, you can even cover up the top numbers with a piece of paper. And if they have the same denominator, that means the answer
Would be an 8
is
on the
also
bottom.
going to have the same denominator. You're not going to add the bottom numbers, okay? Go ahead and put the 8 on the end before we even figure out what they are, okay? That is the case no matter what the numbers are on top, okay? The numbers on the top of these two first, okay, and our first problem here, let's pick some small numbers.
1,
1 and
a 3.
3. Good deal. I like it. So now guess what you do with those numbers.
You're going to add them.
That's it. Not the bottom numbers, just the top number, right? All right, what do you got there?
4.
And would you be finished with that?
Yeah.
Because at the end of the problem, you always want to
Simplify.
simplify, just like we did earlier, right? And so we probably don't need to go through all the work because you already did the work earlier.
Yeah.
What is 4 over 8 simplified?
1/2.
That's it. Go ahead. You can write that down. All right, so, yeah, that's fine. So we have that kind of problem. Uh-oh, not 1/5.
Oh.
Try again. You had it right at the beginning. Good, so you simplified that. Let's do one more. We're going to add these two fractions together, and they have the same number on the bottom. What if we had a 9 on the bottom? Let's pick a couple numbers on the top. What do you think?
A 5.
Okay. Pick the next one.
A 1.
There you go, that'll work. See what you get. First of all, before you do anything at all, and I always encourage my students to do the same thing. Before you do anything at all, what goes in the bottom?
A 9.
9. Put the 9 on there before you do any math so you don't forget. All right, what's next?
Then we're going to add the top numbers.
Yep, go ahead and add them together. Yep, can you simplify that?
No.
Uh-oh, let's see if we can.
Oh, yeah.
Yeah, oh yeah. What can you divide both 6 and 9 by?
3.
You can, that's right. You can't divide them by 2, right? You can divide 6 by 2, but not 9. But you can divide them by 3. So what's 6 divided by 3?
2.
2, that'll go on the top. And what's 9 divided by 3?
3.
3, that's it. So if you have like denominators, you can see it's a pretty straightforward process, right? What if the numbers don't have the same denominator? You saw me do one of those problems like the one in Twitter, right? And so I'd like to go ahead and see if we can add these together, right? 1/4 and 1/3. And I set it all up for you like that because you're going to have to change these numbers, all right? So let's see what you remember from that other problem. What is our new number that's going to go on the bottom of the fractions?
12.
Why 12?
Because you're multiplying the denominators
That's
by each
right.
other.
And that works every time. It's not always the least number, but I will tell you that if you multiply the denominators of two fractions, you will always get a new denominator that will work in the problem. Okay, so go ahead and put 12 on the bottom of those. And remember, we're not changing the value of the fraction. We're only changing how it looks. So how do you make 4 into 12? Multiply by what?
3.
That's it. So what else do we have to multiply by 3? Don't look at the bottom. That's it. So top and bottom by 3. Go ahead. So that means that 1/4 is the same as 3/12. Same value. Okay? Can you do the same thing at the bottom? And let's see if you can do it on your own. 3 times what? Whoa, where'd the 4 come from? What the heck?
1 times 4 is equal to 4.
Yep.
And 3 times 4 is equal to 12.
And that's exactly where you got it, right? You have to pick the number that makes it into 12. That's it. So now you can add those two numbers together. Okay? So the new answer, what's going to be on the bottom?
12.
And what do you do with the top numbers?
Add them.
That's it.
7.
7. And then, of course, your last step is, can you simplify 7 over 12? 2 doesn't go into it. 3 doesn't go into it. 4 doesn't work. You probably have to go all the way up to 7 because 7 will go into 7. Does 7 go into 12?
No.
So we're pretty much good there, right? So we don't need to simplify anymore, but you were able to add two fractions with different denominators.
So one thing I would like you guys to do is, because a lot of times students will get a fraction and they'll be asked to simplify it or make an equivalent fraction. And a lot of times students will simplify it going the lower way.
Yeah?
Can you make an equivalent fraction to 7/12
Oh, I like it.
by making it larger numbers?
Sure. So I want to make sure we're real clear about what's happened, right? You know how to simplify to make both numbers smaller. But look what you did up here earlier. You had 1/3, and we ended up with making both numbers bigger. The question is, can we do the same thing here?
Yes.
What number would you like to have on the bottom?
5.
5, that's not bigger than 12. We want to make sure the number here is bigger, right? Both these numbers are getting bigger. Just like 1 became 4 and 3 became 12, we want to make it bigger. It's because we multiplied by a number. So here's a better question for you. What number would you like to multiply both 7 and 12 by?
5.
Okay, times 5. There we go. Show us the times 5, please. There you go. Good. And you can multiply times 5, or 15, or 50, or 5,000, right? As long as you do the same thing on the top and the bottom. Got to be the same number. All right, let's see what we get. What's 7 times 5?
35.
Nice. 12 times 5?
60.
That's it.
So therefore you have an equivalent fraction, but you, instead of multiplying by 2, you went a little higher, which I like. You multiplied by 5, and there's a lot of different ways you can do that. Nice going right there. Do you guys like things that happen in nature all the time? Do you like to see lightning?
Yes.
I think lightning is awesome. Let's check some out.
What causes lightning? Lightning can be a beautiful and scary part of Earth's weather. You probably have seen lightning in a thunderstorm, but do you know why lightning happens? Lightning comes from electrical charges that build up within a storm cloud. Thunderstorms form when warm, moist air rises high into the atmosphere. This rising air is called an updraft. As air rises in the atmosphere, clouds form when water vapor in the air cools into water drops, called cloud droplets. Some cloud droplets freeze into ice crystals. These cloud droplets and ice crystals collide and form larger particles called graupel. As the ice crystals rise up, they collide with the larger and heavier graupel. These collisions result in positively and negatively charged particles. Ice crystals are small and light. The updraft carries the positively charged ice crystals higher and higher into the cloud. The thunderstorm cloud is mostly negatively charged, which causes a mostly positive charge to form on the ground. When these opposite charges become strong enough, there is an electrical discharge, an energy release, in the form of lightning. Lightning often connects the negative charges in the cloud to positive charges on the ground. This is called cloud-to-ground lightning. Why does lightning often hit trees, telephone poles, or other tall structures first? Trees and telephone poles are often the tallest objects on the ground. So, they are closest to the storm cloud and the first thing in the path of lightning. Lightning can also stay within a cloud or even travel between two clouds. This happens when lightning travels from a negative charge in one cloud to a positive charge within another cloud. This is known as intra-cloud lightning. By the time you see lightning in the sky, a storm is probably already underway in your neighborhood. But tracking lightning from space can help meteorologists predict the intensity of a storm. NOAA's GOES-R series weather satellites captured this imagery of lightning during a series of thunderstorms over the Midwestern United States. Imagery and information from these satellites help forecasters to predict the intensity of a storm and whether or not the storm will produce high winds or tornadoes. Find out more about Earth's weather at NOAA SciJinx.
And just a reminder, we do have phone tutors most Tuesdays and Wednesdays throughout the regular school year for you. Jocelyn, a 5th grade student from Panama, has been nice enough to come in and work on fractions, decimals, and percent all day with us today. So did you learn a little something?
Yes.
Good. And did you have fun today?
Yes.
That's the more important thing right there. So you want to be a fashion designer, correct?
Yes.
All right. Well, here's your first piece of fashion that you're going to... all right. So do you know what that is? That is your new uniform. Is that all right?
Yeah.
She's like, yeah, sure it is, all right. That is what you're going to wear when you're an ambassador. All you have to do as an ambassador is tell other students about Do the Math. Can you do that?
Yes.
You guarantee it?
Yes.
All right, then you have a job as a fashion designer and an ambassador. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.